The reason the second derivative test works is because the second derivative is positive along any section of a curve that is concave up. And concave up means U-shaped. So it's easy to remember because up starts with a U. And negative along any section of a curve that is concave down. Concave down is going to be sort of N-shaped. So here we have a curve with a maximum, a minimum, and a point of inflection. And by that I mean the horizontal point of inflection, because we also have two oblique points of inflection. Those are points of inflection that are not stationary, showing the sign of the second derivative along the curve. So concave up, we can see this section is U-shaped around to here, and the second derivative is positive. The second derivative is then 0 at the oblique point of inflection. Then we have an N-shaped section of curve, so the second derivative is negative. So note, we got this minimum point where the second derivative was positive because the curve is U-shaped. We have this maximum along the section of curve where the second derivative is negative because it is N-shaped. Notice at a horizontal point of inflection how the concavity changes. This is a section that is U-shaped, but it truncates here. If it were to continue along that curve, it would go back up, but it doesn't. It goes stationary and then curves downwards. So the concavity changes always at points of inflection, whether they're oblique, that is, non-stationary ones, or horizontal. So, overall, note, a point of inflection is a point at which concavity changes. There are two types. The horizontal point of inflection, the HPOI, where the first derivative is 0, and oblique points of inflection, opois, where the first derivative is not 0.